Okay, now we're down to Newton's third law. Now, the third law, at first glance, you think, well, this is pretty elementary, and I'm not really sure that I'll ever see where this applies. Um, but we use this law all the time. When we use it, we usually don't say, aha, Newton's third law. We just do what the principle says. What this law says is that if you have a body and the body bears against another body like that, so this guy is in contact with that guy, you can draw a free body diagram with the left piece, and if for whatever reason the force is transmitted, you'll have the force going to the left on this body and to the right on that body. So those are called forces of contact. And it says the forces of action and reaction between bodies in contact have the same magnitude. So if this is F, then this is also F, and the same line of action. So they will share the common line of action. But this one goes to the left and this one goes to the right. Or if it's something sitting on a surface, let's say that you've got an object sitting on a surface, then what you would have is that the object is being pushed upward and the surface is being pushed downward. And so this would be F and F. And usually bodies in contact like that, the force has to be compression unless there's a positive linkage between the bodies. So that's what Newton's third law is. Now, the way that we most often use that is, and I know you don't know what beams are and some of this other stuff, but let me just say it. This is called a simply supported beam. We'll talk more about this as the class goes on. These are some loads that are applied to the beam. It doesn't even matter what they are. This is called a pin support, and this is called a roller support. Don't worry yourself about that. But it could have a horizontal and a vertical. This could have a horizontal or this could have only a vertical. Now let's suppose I make a cut right there. And we'll talk about this later. And I make the sketch over here, draw everything that's over here on the left. And then I draw this other side over here, back in this direction. So I've got this guy, and this guy, see? So what I've done here is I've taken this guy and moved him here, and I've taken this guy and moved him here, and then here's my cut. Now, if I actually took a hacksaw and cut that through there like that and pull this piece over and this piece over here, they would both collapse because that would no longer be stable. The reason they don't collapse is because there are internal forces acting in this body that keep these things together. And we're going to end up breaking these down into axial forces, shear forces, and what we're going to call moments, like this. So the one perpendicular to the surface is axial, the one parallel is a shear, and the one here is a moment. And you see this axial force is to the right, this one's to the left. This one's down, this one's up. This one is counterclockwise, and this one's clockwise. So that's an application of Newton's third law that we will use over and over again as we go on through the class. So, this seems like it's not a very useful thing, but trust me, shear and bending moment diagrams and understanding internal forces in rigid bodies is an incredibly important thing, and it all flows from Newton's third law.